In this lesson about changes of state, we are going to build on what we did last lesson, but let's just do a quick recap so that we know what it is that we're talking about. So the three states of matter, if we remember, are solids, liquids, and gases. Okay, you need to be able to draw the particle diagrams if we remember from last week. So solids being close together and touching, liquids being very close together but not in any kind of order, and then gases usually just one or two particles that are moving very quickly. So we might remember from year 7 that if we change from one state to another, that those things have specific names. If we go from a solid to a liquid, then we call this melting. If we go from a liquid to a gas, we call this boiling. And if we go the other way, so from a gas to a liquid, is condensing. And a liquid to a solid we usually call freezing. So these key words are words that you need to make sure that you remember and that you know these changes of state. So it might be worth you making some flashcards or copying this diagram out and then maybe covering up the words with post-it notes and trying to fill them in. But this is something that you need to be able to remember, these key terms and which ones they refer to. So we have something called a melting point. So this is another key term that you need to know, the melting point. And this is the temperature at which a substance turns from a solid to a liquid. Okay, so something that you should probably know is the melting point of water, so where it would go from ice to water, which is also the same as the freezing point, where it would go from water to ice. So for example, water is 0 degrees Celsius. So that's a fact that you really need to know. We also have something called a boiling point. And this, if we look at this definition here, is very similar. So it's the temperature at which a substance turns from a liquid to a gas. So it's the temperature at which it turns from a liquid to a gas. So if we think about the example that we've just talked about with water, water boils at 100 degrees Celsius. So we could think about an experiment. So if I had a beaker, and in the beaker I had some water, okay, and I applied some heat underneath the beaker, so I could use a Bunsen burner or I could use like an electric heater. Any of those things are fine. And then if I had a thermometer, so using a thermometer to measure the temperature of the water, then we could plot on a graph what this would look like as we increased its temperature. I would draw my axes, and usually we have time because we are going to measure the temperature over a period of time. Okay, so we're going to apply heat, we're going to measure the temperature, we'd measure it every, let's say, 30 seconds. So if we started our temperature at 0, if this is just in the classroom, this water isn't going to be at 0. It's likely to be at about 20, which is room temperature. So we might end up with our graph starting a little bit higher. And what will happen is, as I'm applying the heat, as we're adding energy into this system, for quite a while, the temperature of the water will increase. And that's something that we will already be familiar with. When we heat something up, the temperature of the thing that we're transferring thermal energy to is going to increase. But what happens, the temperature eventually gets to a point where, even though I'm still adding heat, over a period of time, there isn't a temperature change. And this happens at the point that is the boiling point. So this flat part of a graph is telling me that this water is boiling. And if I read across to this axis here, if this was water that we were doing, I would expect this to happen at 100 degrees Celsius, because that is the boiling point of water. So sometimes you might be given a graph like this, and you might be asked to give the melting point or the boiling point from it. So you need to find the flat part of the graph and then put your ruler along it and take it to here and read the temperature off here. So a very interesting thing happens at this point. We're still adding energy, but the energy isn't going towards a temperature change. Okay, so at this point here, there is no temperature change. During a change of state. So this would go for melting, boiling, condensing, or freezing. Any of those things, if there is a change of state, the temperature will not change. And that is because the energy is being used to change the state, so to change where the particles are. So here we've got particles that are very, very close together, packed together very, very tightly, and then we've got particles that are not, they're still together, very close together, but they are not in such solid rows, and then these particles are very far apart from each other. So the position of the particles is changing, and that's what's happening here in this change of state. And this part here we call latent heat. And I know that that's a new word that you won't have heard of before, and we will cover it again in a couple of lessons time, so don't worry about it too much. But the word latent just means hidden. So all it means is that the energy is hidden a little bit here because there's not this temperature change.